Well, hello, 5th and 6th grade. Today's Thursday, October 8th, and this is your science video for today. We have a new section that we're talking about, measuring matter, and, well, that's part of it anyway, but we're talking about matter and other things, and so we're going to be talking about how things melt, how things have different melting points, the temperature, how to take the temperature. We'll be doing that tomorrow. Being able to take the temperature of different things, and I'll figure out a way to allow you to do that individually so that you can be distanced from each other at the same time. So, all right, so on your work text today is going to be page 40. If you look there, it's basically asking you to do a few things here. You have three sections. The first section is basically asking you to answer the question of a tool. Which one would be used to do the thing that's described in those numbers? And you put the letter there in the blank. And then fill in the circle for the correct answer as to what is happening in the story or that's described in the sentences, and then you tell what that was that happened. And then on the last one, it's asking you to do the volume of a box. Now, just to give you, this is the same thing of a rectangular solid in math. And to do the volume, it's sort of like doing the area inside the box itself. And so you measure the length times width like you would normally do with a rectangle, but then you also multiply that by the height, and that gives you the volume, and it's in cubic whatever it is. And so centimeters cubed or inches cubed. Usually in science you're going to use the metric system, so that would be your primary thing. All right, so let's go ahead and look at page 58. This is your reading for today, so I'll read it. You can speed it along if you want, if you think I don't talk quickly enough, but don't do too fast so that you're really not keeping up. And remember, you should be following along with your book while I'm doing this. And as we looked at those things, you'll understand how to do certain things here. Let's do this first. Let's go to the science in the Bible at the bottom. It says in 2 Kings 4, the Bible tells us about a widow who owed money. Her sons were going to be taken as slaves unless she could pay her debts. All that the widow had was a pot that held a small volume of oil. The prophet Elisha told the widow to borrow vessels or large containers from her neighbors. She started pouring her little bit of oil into the vessels and kept pouring until all the vessels were filled. Elisha told her to sell the oil to pay her debts. God caused the small volume of oil to increase to fill many large pots. In this way, he miraculously provided for the widow's needs. Then it says there in measuring matter at the top, it says, serving others often involves using objects. Andrea used ingredients and utensils to make her brownies. And this is from yesterday's reading that you should have done, where it talks about everything was at the same melting point. You were going to make brownies, and at the point the chocolate melted would be the point that everything else melted. That could cause a gigantic mess. And so obviously different things have different melting points, and that helps us to do certain things. And imagine how it would be affected if our cars melted when the temperature got above 90 or something like that, and we just had these big piles of liquid on the ground outside. So it does make a difference. And so it says here, I'm looking for where it was. Okay, so it says, although objects are different in many ways, they are also alike, or they are all alike in at least one way. Each is made of matter. Now, these are important to understand the definitions of matter and weight and things like that we're doing. But right now we're talking about matter. Matter is anything that has volume and has mass. Volume and mass are characteristics of matter that we can often measure. Sometimes we use the term substance to refer to matter. Right? The volume of a liquid. The volume of a substance is the amount of space that it takes up. The standard unit of metric measurement for volume is the liter. Again, metric system is what we're using. And so many soft drinks come in 2-liter bottles. And you guys have, I'm sure, purchased or had drunk from one of those. A smaller unit for volume is the milliliter, M capital L. And the reason we don't do ml, little l, is because that looks like miles, or mi for miles. So that's why it's little m, capital L. Liquid medicine often uses this unit. A teaspoon of medicine is about 5 milliliters. We measure the volume of a liquid by using a graduated cylinder, or graduated container. Graduated means that the container is divided into equally marked parts. A graduated container has the units of measurement marked on its side. A liquid is poured into the container. The level of liquid is then compared with the numbers on the side of the container. The numbers show the volume of the liquid. Scientists use containers called graduated cylinders, but even the measuring cups in a kitchen are a type of graduated container. In fact, that's what I've used in some of the experiments that we've done. Volume of a solid. There are two ways to measure the volume of solid objects. To measure the volume of regular shapes, such as cubes and rectangular solids, multiply the measurements of the length, width, and height of the object. The volume is written as a cubic measurement. An object that is 15 centimeters long, 10 centimeters wide, and 10 centimeters high has a volume of 1,500 cubic centimeters. A cubic centimeter is written as cm to the third power, or cc, cubic centimeters. But in our class, we'll write it cm to the third power because that'll help with math later on. However, we cannot always measure a solid object by using its length, width, and height. For instance, it would be difficult to measure a rock or a marble in this way. The volume of irregularly shaped objects can be measured using a method called water displacement. You can see the water displacement when you add marbles in the water, to the water in a graduated cylinder. The volume of the marbles is the difference between the beginning level of the water and the level after the marbles were added. The volume can be written in milliliters or liters. For example, suppose the cylinder contains 250 milliliters of water. After the marbles are added, the water level is at 300 milliliters. The volume of the marbles then is 50 milliliters. Makes sense, right? All right, it says in a metric system, a cubic centimeter is equal to 1 milliliter. All right, so a cubic centimeter of space is equal to 1 milliliter of volume. And so scientists usually use milliliters to describe the volume of a liquid. They use cubic centimeters to describe the volume of a solid. So the volume of the marbles in the example is also equal to 250 cubic centimeters. All right. Now, let's look over at mass and weight. It says mass is another way that matter is measured. Mass is the amount of material in a substance. All right. Now, some of you had some of those rocks, and if you got a piece of lava rock or any kind of a pumice rock, it has a lot of bubbles or holes that are in it. You'll notice that rock is a lot lighter, and it may be the same size as a different one, but it's a lot lighter. That has to do with mass, how much material is in that rock at the time. And so it says it's usually measured by comparing an unknown mass with a known mass. For example, a student with an unknown mass can sit on one end of a seesaw. A substance with a known mass, such as a sack of sand, can be placed on the other end. If the seesaw balances, we know the mass of the student is the same as the mass of the sand. We usually measure mass with an instrument called a balance. And we have already showed you the triple beam balance and how that works. And by the way, your secret word is balance. And so that is your secret word for science. And it says that standard masses, standard masses and objects of known masses are used to balance the unknown mass of the substance. The mass of the substance to be measured is equal to the sum of the standard mass. Okay, so added together. Some metric units of mass are the gram and the kilogram. The mass of a paperclip is about 1 gram. So if you had a kilogram, that's 1,000 grams. 1,000 paperclips is what that would weigh. A 1 liter bottle of water has a mass of about 1 kilogram. It's usually easy to determine which of two objects has the greater mass. A large dog has more matter than a small cat does, and therefore has more mass. And if the dog eats the cat, then the dog even has more mass after that. Now, dogs don't eat cats usually anyway. Usually cats get angry at the dogs, and then they beat them with their claws, and the dogs go away whimpering. But anyway, the dog also weighs more than the cat does, but the dog's mass and the dog's weight are not actually the same thing. All right, and so mass and weight are related, but they measure different things. Mass measures the amount of matter, the amount of material in that thing. That's the mass, okay? And that's what you measure with the triple beam balance. Weight, though, it says weight measures the amount of force gravity exerts on the matter. So that matter that's in there, gravity makes a difference as to the weight of it. On the moon, everything on the moon is 1/6 the weight of what it would be on the Earth. And so it's a different gravity level. And so it says that if we measure two items in the same location, the object with greater mass weighs more. And that's on the Earth. That's natural that would happen. We have the same pull of gravity here on the Earth. Mass can change only as the amount of matter changes, but weight can vary based on the gravity at a location. Students whose mass is 40 kilograms would weigh 88 pounds on the Earth. 1 second. That was Mrs. Jones. She needed a locker stand for somebody. So, all right, mass can only change. We already said that, right? A student, but that student would weigh about 220 pounds on Jupiter and only 15 pounds on the moon. So the difference occurs because the gravity of the moon and the gravity of Jupiter are different from the gravity of the Earth. And we always measure everything on the Earth because not many of us have been to the moon or Jupiter. Although sometimes when I'm looking at you while I'm teaching class, especially language, it looks like some of you are visiting Jupiter or the moon at that time in your brains. All right, so density. Density is the amount of matter in a certain volume. Suppose you're given the task of carrying 1 or 2 boxes in a race. The 2 boxes are the same size and look the same on the outside. However, one box is filled with cotton, the other box is filled with rocks. You would probably choose the box with the cotton inside. The 2 boxes have the same volume, but the box with cotton has less mass than the box with rocks has. This difference in mass makes the box of cotton less dense than the box of rocks is. The density of an object is calculated by dividing its mass by its volume. The formula mass divided by volume equals density. All right, and you're going to need to know that and be able to figure some things out later on. And it says an object that has 12 grams of mass and takes up 3 milligrams of volume has a density of 4 grams per milliliter. Notice this density is measured in grams per milliliter. It is written in as G, and then the slash would be like a fraction per milliliter. G slash milliliter, grams per milliliter. Now, look at the density of different objects there on the left side. You've got the gold, which has a very high density. Lead, silver, water, ice. Notice that ice, even though it is water, when it's frozen, it actually has less density. Kind of an interesting thing. That's why ice floats on liquid or in water. If you make water, the ice floats. You don't have water forming at the bottom of the glass, so you always have it forming where? At the top of the glass. Wood, pine wood is 0.7 grams per milliliter. Wood, oak wood is less. And cork, which you guys are familiar with, cork is very light. All right, creation corner at the top there. Most substances have a greater density in a solid form than in liquid form. One exception is water. During the winter, ice floats on top of lakes and rivers instead of sinking. If the ice sank, it would continue to displace the water. The water on top would freeze and sink. All the living things in the water would die. However, God designed ice to be less dense than water. In this way, He provided a top layer to preserve life under the ice in the water. In the winter. All right, so that is your reading for today, and don't forget about that secret word. If you missed it, it's back there somewhere between 6 and 8:30. I won't tell you exactly where. Minute 6 through 8:30 is the secret word. All right, that's it. Have a good day. We'll see you on Friday. Bye.